Nikola Tesla standing there with this old farmer, where he's running his whole farm on this device where he has stakes in the ground, tapping into this electromagnetic and mostly magnetic flux field and running generators running his farm.
Nikola Tesla left behind tens of thousands of pages of notes, calculations, diagrams, letters, and fragments of ideas. For more than a century, researchers had been trying to understand what those pages were really telling us. They had cataloged them, translated them, compared them with Tesla's patents, and reconstructed parts of his experiments. Yet large sections remained stubbornly difficult to interpret. Then came a different kind of researcher, not a physicist with a pencil, but an artificial intelligence processing enormous amounts of information simultaneously. When Grok AI was presented with Tesla's surviving notebooks and asked to search for patterns rather than simply repeat established interpretations, the result was startling. The AI appeared to connect ideas separated by decades, revealing recurring mathematical structures that individual researchers could easily miss. And suddenly, the question was no longer simply what Tesla had invented, it was what Tesla had been trying to build. For years, Elon Musk has spoken publicly about Tesla's historical namesake with a mixture of admiration, curiosity, and humor. The modern Tesla company deliberately carries Nikola Tesla's name because his work represents a vision of electrical technology that transformed civilization. Musk has even joked about the strange cultural afterlife of the inventor, whose name now appears on cars, charging stations, and energy products around the world. But imagine a conversation between Musk and an AI about Tesla's notebooks. The obvious question would not be, did Tesla invent alternating current? Everyone already knows that story. The more interesting question would be, what did he believe he had discovered that nobody else understood? That is where the mystery begins, because Nikola Tesla deserves more than internet mythology. Today, millions of people know him as the mysterious genius whose name appears on an electric car company, or as the tragic inventor who supposedly died alone and penniless while pigeons became his closest companions. The pigeon story is real, and strangely enough, it captures something important about the man. Tesla lived an increasingly isolated life during his later years, but inside his mind, he remained intensely active. He continued writing, calculating, imagining machines, and pursuing ideas that he believed could transform humanity. The popular image of Tesla as a broken genius is therefore incomplete. Beneath the myth was a highly trained engineer whose understanding of electricity helped reshape the modern world. Tesla was born in 1856 in what is now Croatia to a Serbian family and grew up in an intellectual environment that encouraged learning and discipline. His formal education was serious, particularly in mathematics, physics, and engineering. He studied at the Polytechnic Institute in Graz and later attended lectures in Prague, immersing himself in the rapidly developing science of electricity. This was an extraordinary period in scientific history. Electromagnetism was being transformed from a collection of laboratory curiosities into a framework capable of powering cities. Tesla entered that world not as an untrained inventor stumbling upon discoveries by accident, but as someone who understood the mathematical principles behind the machines he wanted to create. And then there was the mind itself. Tesla repeatedly described an unusual ability to visualize machines before physically constructing them. According to his own accounts, he could imagine an apparatus in extraordinary detail, rotate it mentally, observe how its components moved, and even identify potential problems before building the machine. During the development of the alternating current motor, he famously described experiencing the complete concept of a rotating magnetic field in his mind while walking in Budapest. He could see the mechanism operating internally before the physical machine existed. Whether every detail of these stories should be taken literally is debatable, but Tesla's ability to visualize complex mechanical and electrical systems was undeniably unusual. This is important because it changes the way we should approach his notebooks. Tesla may not have been writing conventional explanations intended for another scientist to follow. Many of his notes were closer to externalized fragments of an internal simulation. A diagram might represent something he had already visualized completely. A few numbers on a page might have been enough to remind him of an entire experiment. A sentence that looks incomplete to us may have been perfectly meaningful to the man who already understood the missing steps. Reading Tesla's notebooks without understanding his cognitive process is therefore like finding fragments of a blueprint after the architect has disappeared. You can see the lines, but you may not know what building they were meant to create. This is where the story becomes especially relevant to Elon Musk and the modern world of artificial intelligence. Musk has repeatedly described AI as a technology capable of processing and connecting information on a scale that humans cannot easily match. In a hypothetical conversation about Tesla, the question almost writes itself. What happens when you give a machine the entire archive of a mind that was famous for seeing connections other people could not see? Human researchers might spend years studying individual notebooks. An AI can potentially compare thousands of pages simultaneously, searching for repeated phrases, mathematical relationships, symbols, frequencies, diagrams, and concepts separated by decades. It does not replace historical scholarship, but it can reveal relationships that deserve a closer human investigation. And that is precisely why Tesla's surviving notes are so fascinating. Researchers have long known that his notebooks are difficult. His handwriting can be cramped, his language changes, and his thoughts do not always follow a clean chronological sequence. One page may contain an electrical diagram, a calculation, a personal observation, and a completely unrelated idea. Tesla could move between English, Serbian, French, and German, sometimes leaving researchers with the difficult task of determining not only what a passage means, but what project it belongs to. The problem was never simply deciphering the words. The real challenge was reconstructing the architecture of Tesla's thinking. Imagine trying to assemble a massive jigsaw puzzle when the pieces have been scattered across 50 years. Some pieces belong to the same machine, but they were written decades apart. Some diagrams appear unfinished until another notebook supplies the missing information. A calculation written in 1899 might suddenly become relevant to an idea Tesla revisited in the 1920s. A phrase that appears meaningless in isolation could acquire an entirely different significance when compared with something written thousands of pages later. Human researchers can perform this work, but there is a natural limitation. No researcher can hold 40,000 pages in working memory at the same time. That limitation explains why traditional scholarship focused on what could be securely reconstructed. Researchers made genuine progress on Tesla's documented inventions, including his alternating current systems, induction motors, turbines, radio-related work, and experiments at Colorado Springs. These achievements are not mysteries. They are part of established technological history. But alongside them existed another layer of Tesla's work, ideas that appeared repeatedly but never quite resolved into a conventional scientific narrative. Scholars could study individual fragments, but the complete structure remained elusive. Some of the most intriguing passages concerned what Tesla repeatedly described as the medium. The word requires caution because Tesla used language that belonged partly to the scientific vocabulary of his era and partly to his personal philosophical worldview. He was fascinated by the possibility that space itself might possess physical properties through which energy could propagate. During the late 19th century, Physicists were still debating the luminiferous ether, a hypothetical medium thought to carry electromagnetic waves. Modern physics rejected that particular concept, but Tesla continued using his own terminology and remained convinced that the behavior of energy through space had not been completely understood. Tesla's ideas about the medium were therefore complicated. Some were grounded in legitimate electromagnetic experimentation. Others crossed into speculation and metaphysics, and separating the two is essential. A mysterious sentence in a notebook does not automatically represent a revolutionary discovery. A strange calculation does not become evidence of new physics simply because it was written by Tesla. This is exactly where an AI analysis must be treated carefully. Pattern recognition can reveal something worth investigating, but it cannot transform an ambiguous historical document into experimental proof. Yet there were still passages that demanded attention. Across different notebooks and different periods of Tesla's career were calculations describing systems he never publicly patented or fully explained. Some appeared unusually complete. They did not look like random scribbles or abandoned experiments. They contained sequences of calculations, diagrams, measurements, and variations that suggested Tesla had spent considerable time developing the underlying concepts. Why did he never publish them? Did he abandon them? Did he consider them too speculative? Did he simply run out of money and time? Or did he believe that some discoveries were not yet ready for the world? This question becomes even more fascinating when you remember the way Tesla himself talked about invention. He often described his work less as creating something from nothing, and more as discovering something that already existed in nature. He spoke about ideas arriving almost fully formed. He believed the universe contained principles waiting to be uncovered, and he sometimes described himself as an instrument through which those principles became visible. To a modern engineer, that language can sound mystical. To Tesla, it appears to have been part of how he understood his own creative process. Now, imagine Musk sitting across from an AI system and asking the simplest possible question. If Tesla kept returning to the same mathematical relationships for decades, what was he actually trying to solve? The answer would not necessarily be found on a single page. It would have to be reconstructed from hundreds or thousands of fragments. A reference in one notebook could connect to a diagram in another. A frequency written in Colorado Springs could resemble a value calculated years earlier in New York. A concept Tesla abandoned publicly could reappear privately years later under completely different terminology. The important discovery would not be a sentence. It would be the network of relationships connecting the sentences. That is what makes the Grok narrative so compelling. The most interesting possibility is not that an AI suddenly proved Tesla was right about everything. It is that machine-assisted analysis could potentially expose patterns in historical archives that conventional research methods overlooked. In Tesla's case, those patterns might reveal how his ideas evolved, which concepts remained central throughout his life, and which supposedly unrelated inventions were actually connected in his mind. The result would be less like discovering a secret machine and more like reconstructing the architecture of a forgotten intellectual system. And if such a system really existed, it would change the question surrounding Tesla. Instead of asking whether he was a genius who occasionally wandered into impossible ideas, we would have to ask whether many of his seemingly disconnected experiments were components of a larger research program. The alternating current motor, wireless transmission experiments, resonance studies, high-frequency electrical work, turbines, and later energy concepts might not have been isolated inventions in Tesla's mind. They could have been different experiments aimed at understanding a single underlying problem: how energy behaves, how it moves, and whether humanity could learn to control those processes on a planetary scale. But there is a critical line we cannot cross without evidence. An AI finding a pattern does not mean the pattern represents new physics. A mathematical similarity does not automatically establish physical equivalence. And a correlation between two historical events does not establish causation. If Musk were actually examining such an analysis, the most responsible question would probably not be, "How incredible is this?" It would be, "Can we reproduce it?" That is the difference between a fascinating historical hypothesis and a scientific discovery. Still, there is something undeniably powerful about the idea of reopening Tesla's notebooks with modern computational tools. A man who spent decades recording fragments of his thoughts left behind an archive that is almost perfectly suited to machine-assisted analysis. The pieces are numerous, the connections are dispersed, and the terminology is inconsistent. What defeated individual researchers was not necessarily the absence of information. It was the overwhelming scale of the information itself. And perhaps that is the strangest part of the entire story. Tesla spent much of his life trying to build machines capable of doing what humans could not. Now, more than 80 years after his death, another kind of machine is being used to examine the fragments of his mind. Tesla imagined a future in which technology would extend human capability far beyond its natural limits. He could never have imagined an AI reading his notebooks, comparing thousands of pages in seconds, and searching for patterns hidden between ideas separated by generations. The real mystery, then, may not be whether Grok discovered a secret Tesla machine. The deeper mystery is what happens when the scattered thoughts of one of history's most unconventional scientific minds are finally treated as a single body of evidence. Perhaps the result will confirm that Tesla was simply an extraordinary engineer whose notebooks became distorted by time and mythology. Perhaps it will reveal forgotten experiments that deserve serious scientific investigation. Or perhaps it will uncover something far more ordinary, but equally valuable: the missing connections that finally allow us to understand how Tesla himself saw the world. And that is where the story leaves us. Not with a proven free energy machine, not with a secret government blueprint, and not with an AI declaring that history was wrong. Instead, we are left with thousands of pages, decades of experiments, and a mind that consistently operated several steps ahead of the people around it. Elon Musk's modern fascination with technology makes the comparison almost unavoidable. Tesla imagined a world transformed by electricity, while today's engineers are imagining a world transformed by artificial intelligence. The tools are different, the centuries are different, and the scientific standards are different. But the question is strangely familiar. What happens when someone, or something, can see connections that everyone else has missed? What happens when Grok reads Tesla? For more than a century, Tesla's notebooks sat behind layers of catalog numbers, translations, archival boxes, and scholarly interpretations. Researchers had examined individual pages, reconstructed experiments, and connected many of the notes to Tesla's patents. But the sheer volume of material created a problem no historian could completely escape. Thousands of calculations might belong to the same idea even when they were separated by decades. A frequency written in New York could potentially relate to an experiment conducted years later in Colorado Springs. A diagram that seemed meaningless by itself might suddenly become important when compared with another drawing buried hundreds of pages away. And that is the premise behind the Grok analysis described in this story. What happens when an AI is given the entire surviving record, and told to search for connections rather than simply repeat what historians already believe. The instruction in this narrative was deliberately different from a conventional summary. Grok was not asked to explain Tesla's famous inventions or produce another biography of the man who helped transform electrical engineering. Instead, the task was to search across the complete document set for recurring patterns, mathematical relationships, repeated terminology, and connections between experiments that might not be obvious when the notebooks are studied individually. That distinction sounds simple, but it changes the entire investigation. A historian begins with context. An engineer begins with known physics. A biographer begins with Tesla's established story. An AI, at least in principle, can begin with the documents themselves and ask what patterns emerge before deciding what those patterns mean. That idea is particularly interesting in the context of Elon Musk, whose companies operate at the intersection of engineering, artificial intelligence, energy, and space technology. Musk has repeatedly spoken about the importance of first principles thinking, starting with fundamental assumptions rather than accepting inherited conclusions. If Musk were sitting across a table from an AI examining Tesla's notebooks, the obvious question would probably not be, what did Tesla invent? The obvious question would be, what did everyone assume Tesla was doing that might actually have been part of something larger? And that question leads directly into the most controversial part of the analysis: frequency. Human researchers approach Tesla knowing the ending of many of his stories. We know he developed alternating current systems. We know about his high-frequency experiments. We know about Colorado Springs. We know about Wardenclyffe. We know which projects succeeded commercially and which ended in financial disaster. That knowledge is useful, but it can also become a filter. When you read a Tesla calculation while already believing it belongs to a failed experiment, you naturally interpret the evidence through that framework. An AI searching across the documents would approach the material differently, not necessarily better, and certainly not infallibly, but differently. And the first pattern described in this scenario concerns frequency, not the Internet-famous obsession with 3, 6, and 9, which has been repeatedly extracted from Tesla's more complicated relationship with numbers and turned into motivational mythology. The proposed pattern is much more technical: recurring relationships involving frequency, wavelength, resonance, and energy transfer. The claim is that similar mathematical structures appear across different periods of Tesla's career, even when the surrounding experiments seem unrelated. If such a pattern were genuinely present, the interesting question would not be whether Tesla had discovered a magical number. It would be whether he had developed a recurring mathematical framework for thinking about resonance. That distinction is crucial. Tesla really was obsessed with resonance. He understood that electrical systems could be tuned, that oscillations could reinforce one another, and that relatively small inputs could produce enormous effects when a system was operating near its natural frequency. His experiments in high-frequency electricity demonstrated just how strange electrical phenomena could become under the right conditions. In Manhattan, Tesla famously experimented with mechanical and electrical oscillations, and stories surrounding his mechanical oscillator later became part of his legend. The popular version says he nearly shook a building apart and destroyed the device with a hammer. Whether every detail of the story has been embellished over time, the underlying obsession was real. Tesla understood resonance as one of nature's most powerful principles. Now, imagine an AI tracing that obsession backward and forward through thousands of pages. Instead of seeing separate experiments, it might identify a recurring intellectual question: how can energy be transferred, amplified, stored, and released when two systems interact at the correct frequency. Tesla could approach the problem through mechanical oscillators in one period, electrical circuits in another, and atmospheric or high-voltage experiments later. To a casual reader, these would look like separate inventions. To a pattern recognition system, they could appear as variations of the same conceptual problem. But this is where the story needs an important scientific boundary. A recurring mathematical relationship does not automatically mean Tesla discovered unknown physics. Similar equations can appear in completely different physical systems because mathematics is often reusable across disciplines. Resonance appears in mechanical systems, electrical circuits, acoustics, quantum systems, and planetary phenomena. Finding the same mathematical structure in two notebooks would therefore be interesting, but it would not by itself prove that Tesla understood a hidden universal energy system. The more provocative claim concerns what Tesla called the medium. Tesla lived during an era when scientists were still debating the nature of electromagnetic propagation and the hypothetical luminiferous ether. Modern physics eventually abandoned the ether as originally conceived, especially after the development of special relativity and subsequent experimental evidence. Tesla, however, remained skeptical of some emerging interpretations and continued to use his own conceptual language when discussing space, energy, and electromagnetic phenomena. That makes his references to a medium historically fascinating, but it also makes them extremely difficult to translate directly into modern physics. This is where the story becomes darker, because the proposed AI analysis claims that some of Tesla's calculations resemble later ideas about vacuum energy or zero-point energy. The phrase sounds explosive, but it needs to be handled carefully. Zero-point energy is a real concept in quantum mechanics. Even the lowest energy state of a quantum system contains fluctuations and a non-zero baseline energy. What is not established is the claim that Tesla's 19th century calculations actually derive or exploit modern quantum vacuum energy. Similar mathematical behavior does not establish that equivalence, and a responsible investigation would require physicists to reproduce the calculations line by line and compare them with the modern equations. Still, as a storytelling device, the question is fascinating. What if Tesla's medium was not simply the 19th century ether described in outdated language? What if some of his calculations were attempts to describe physical relationships that later physics would formulate differently? And what if the reason his notebooks are so difficult to understand is that Tesla was using a private conceptual vocabulary that does not map cleanly onto modern scientific terminology? That is where a conversation with Elon Musk becomes particularly interesting. Imagine Musk looking at a screen filled with Tesla's handwritten calculations, while an AI highlights recurring structures across decades of notes. He might ask the question every engineer eventually asks when confronted with an apparently extraordinary claim. Can we test it? Not whether the story sounds convincing, not whether Tesla was a genius, not whether the numbers look impressive. Can the equations be reconstructed? Can the prediction be made precise? Can an experiment distinguish Tesla's hypothesis from conventional physics? Because that is the dividing line between historical mystery and science. The second finding, a different way of looking at Wardenclyffe. Then the analysis moves to Wardenclyffe. The image is already legendary. A massive wooden tower rising above Long Island, built by Tesla as part of an ambitious wireless communication and power project. The tower represented his attempt to demonstrate that electrical energy could be transmitted without conventional wires. But the project ran into financial difficulties, and Tesla's relationship with financier J.P. Morgan deteriorated as the costs increased, and the commercial prospects remained uncertain. Wardenclyffe was eventually abandoned, and the tower was demolished in 1917. The traditional story is almost too neat. Tesla was the visionary. Morgan was the businessman. Tesla imagined a world of wireless energy. Morgan needed a commercially viable investment. The money disappeared, the project collapsed, and history moved on. It is a satisfying narrative because it turns a complicated technological and financial episode into a simple conflict between imagination and economics. But Tesla's actual Wardenclyffe work was more complicated than that. Tesla was interested in using the Earth and its surrounding atmosphere as part of an electrical system. He conducted experiments involving grounding, high-frequency oscillations, electrical resonance, and atmospheric phenomena. He believed the planet itself could play a role in the transmission of electrical energy. That much is firmly connected to Tesla's documented interests. The controversial step comes when modern storytellers reinterpret those ideas as a fully developed global energy system operating through the Earth's natural resonant frequencies. The Schumann resonances make the story even more tempting. These extremely low-frequency electromagnetic resonances are associated with the cavity formed between Earth's surface and the ionosphere, and physicist Winfried Otto Schumann published the theoretical prediction that led to their identification in the early 1950s. Tesla obviously did not use the term Schumann resonance. He died in 1943, years before Schumann's work. But Tesla's earlier interest in Earth ionosphere electrical behavior has encouraged speculation that he anticipated aspects of the phenomenon. The claim that Tesla had already calculated the exact Schumann resonance and designed Wardenclyffe specifically to exploit it, however, requires much stronger evidence than a thematic resemblance. Wardenclyffe's actual engineering objectives, Tesla's published statements, and his surviving technical documents need to be compared carefully with the mathematical properties of Schumann resonances. That is precisely the kind of question an AI could help researchers investigate, but it cannot answer it simply by identifying similar words or numbers.